Right, let's continue. Now, remember now like we're doing the mechanism. So, we ended up, like in the last lecture, we ended up with two aldehydes, right? One, this was our acetaldehyde. This bonded to, there's my aldehyde. Remember this one now, like it's a CH2 bonded to H, that's a CH3, right? So, you've got an OH minus coming from your Na plus. There's your OH minus. What happens here? Remember the chemistry behind. Here, oxygen pulls the electron density here via this, what you call like the sigma framework, and then the alpha position releasing electrons to stabilize that charge, and then now this now like taking away electrons away from hydrogen. So hydrogen meaning that now like it can easily fall off. These hydrogens here at the alpha position, they are what? They are acidic. Then they can easily be abstracted by what? By a base. There's the abstraction here, right? Now, this proton here leaves behind those electrons, leaves them with that carbon atom to generate a carbanion at that particular stage. So what do I form here now? There's my CH2. These are the what you call like electrons that have been left behind by hydrogen. Therefore, this carbon atom becomes negative in charge. This carbon was bonded to this here, bonded to hydrogen there. Now, there's a source of electrons here, single bond, and a source of electrons there. Then there's conjugation. So this here will come over here to generate a double bond, right? And then this here. So this carbanion is a resonance what? Stabilized, right? So in this case now, we generate our CH2. Then there's a double bond here now. Single bond, O, 1, 2, 1, 2, 1, 2. Now the negative charge has been transferred to the what? To the oxygen. So this is the enolate, right, of your acetaldehyde in this case, right? So this is what we end up with. So this is our first step. First step is the formation of the enolate, enolate of what called like of acetaldehyde, right? Let's go now to the condensation step. Remember, there we had our ring. That is the second aldehyde. There's our ring here. We ended up with a system like this, double bond O, 1, 2, 1, 2. Then this hydrogen. This here was your NO2. So it reacts with what? CH2, this minus, this, that, double bond, 1, 2, 1, 2, this hydrogen here. So what's going to happen here is that now this now comes in and attack at the electrophilic center here, comes in as a nucleophile. This goes out, and then what then do we form here now? We form this. There we go, double bond, double bond, double bond, my NO2, right? And then this here, there's my oxygen, 1, 2, 1, 2, 1, 2, which is negative in charge. And then this is to the what? To my CH2 this side. CH2 that is bonded to double bond O, this 1, 2, 1, 2. Then remember here, this carbon here was bonded to a hydrogen. There's a hydrogen atom sitting there, right? So we generate that enolate, right? Now remember here, OH, this, there was water that was formed there as a byproduct, H2O in that case. Now that H2O, there's my water, H2O, there we go, 1, 2, 1, 2. This now comes and pick up a proton here as it leaves, right? Then we generate now like next step, we get the beta hydroxy aldehyde. we get our beta hydroxyaldehyde. There's my NO2, this, that CH2, this double bond O, 1, 2, 1, 2, this here, H, that's a CH2, this is CH here, then O, H, 1, 2, 1, 2. Then I've generated a beta hydroxy carbonyl compound in this case, right? Now, of which I can easily treat this now with acid, right? In the presence of heat, this will take away water, OH and H here, to form a double bond. This is what we get in this case. This here, this is NO2, this, that, there's my double bond. This, that, H there, 1, 2, 1, 2. So I have now generated my alpha, beta, unsaturated what? A skeleton, right? Which gives me my target molecule in that case, right? So don't fear organic chemistry. The lecturer is using a benzene ring there with a nitro group just to confuse you. Don't allow the lecturer to confuse you, right? Don't allow him to play with your mind. It's very easy, this thing, right? Okay, I'll see you in the next class. Thank you.